Assalamualaikum and greetings. In this video, we're going to discuss another question related to the synthetic sequences of the benzene derivative. So, in previous chapter, we already highlighted some of the subtopics that you should know, such as the auto para director and so on. This is another form of question that can be asked. The difference between the two questions is, in the previous example, you are required to draw a benzene derivative. For instance, if you have a benzene compound, okay, let's say this is nitro and then you have chlorine. So you are given a compound and then you need to produce this compound, this derivative, from unsaturated benzene. So for the question, you need to arrange the sequences, whether you're going to add the chlorine or you're going to add the nitro first. Okay, that is depends on your comprehension on how the electrophilic substitution is going to work. Okay, you're going to decide for this compound, for instance. Okay, which reaction should occur first? Is it the chlorination or is it the nitration process? So it depends on the structure of the end product. So in this case, chlorine is the ortho para director while nitro is the meta director. Therefore, since the compound is in the ortho configuration, clearly you need to insert the chlorine first, okay, because the chlorine need to become the landlord of the benzene, and then it's going to instruct the nitro to be assigned at the ortho position. So for this question that we're going to discuss right now, okay, instead of you need to propose the synthetic sequences, we need to follow the sequences that has been written in the reaction scheme. What I meant was, okay, you don't need to worry to arrange which should come first, because you just follow the reaction, follow the diagram lah, the follow diagram that is given. For instance, we're going to start off with unsaturated benzene. Then there are three reactions. There are three initial reaction. First, we're going to react it with chlorine with AlCl3, and then we're going to react it with reagent 1, and then we're going to react it with reagent 2. So this is the three separate reactions. And then after the initial reaction is going to be followed up by the second reaction. For instance, for this one, we react it with reaction Y, which comprises of CH3COCl and also AlCl3. For this one, we are using sulfonation. So just to recap, sulfonation is referring to one of the electrophilic substitution reaction, which using SO3 and also sulfuric acid as the catalyst. And finally, we have reagent 2. Just now, we react with CH3. And we're going to react with chlorine. However, in this case, we're going to use sunlight. Alright, sunlight also can be written as UV, or instead of using UV, we can also use heat, okay, to proceed with this reaction. So for this question, all of the reaction is the electrophilic substitution reaction, except for this one. And I believe that you are familiar with this reaction that we have discussed in chapter 2. Okay, the reaction of alkene, the free radical substitution. Okay, before we go further, let's take a look at the question. Okay, for question number 2, consider the following reaction. As you can see here, again, we have a single benzene which is going to be reacted with a certain reagent. Okay, in total, there are 3 reactions followed by the electrophilic substitution reaction. And the question clearly states that illustrate the structural formula of CDEF. Okay, here the compound CDEF. Identify the reagent 1 and 2, including the condition, if any. So this is reagent 1 and also reagent 2. Identify the name of reaction Y. Okay, you need to name this. Okay, please take note that there is a difference between the name of the mechanism and then the name of the reaction. Right, these are two different things. For instance, most of the reaction that we discuss is based on the electrophilic substitution reaction. Okay, electrophilic substitution reaction. And under electrophilic substitution reaction, we have a series of reaction that is following this mechanism. Okay, the electrophilic substitution reaction is the mechanism, while under the electrophilic substitution reaction, we have what we call as nitration, halogenation, okay, the Friedrich-Krafft acylation. Yeah, there are two types, okay, Friedrich-Krafft acylation, there is acylation, and then there is alkylation. Right, the common thing about them is they'll be using aluminum chloride as the catalyst. This is referring to the Friedrich-Krafft, and of course we finally have sulfonation, which are using SO3 in sulfuric acid. Okay, we're going to take a look at this later on. And the last question is related to the mechanism. Right, for mechanism, okay, again, for this video, we're going to discuss the synthetic sequences. Alright, and synthetic sequences with the mechanism is not the same. It relates to one another, but it is not the same. The synthetic sequences, we are looking for the process, process to produce the benzene derivative, while the mechanism is explaining what happened during each process. Okay, during each process, step by step. Okay, we're going to take a look at the movement of the electron. Alright. Okay, so this will be it. So let's take a look on how to answer the questions. Okay, again, I just put another image. Alright. Okay, for this question, let's take a look first at the first question, which is benzene. Okay, for the first step, we're going to take a look at this first reaction. So for this reaction, as you can see here, we are using Cl2 together with AlCl3. Alright, for this reaction, instead of using AlCl3, we can also use iron chloride. Okay, please refer to your notes. And then Cl2, whenever, in this case, as you can see here, when we add the Cl2 with AlCl3, what's going to happen is one of the hydrogen, to be precise, this part of the hydrogen will be replaced with Cl. Any addition of halogen compound to the benzene ring or to other compound can be identified as the process of halogenation. Right? In this case, okay, it replaces the H, which is bonded directly to the benzene. So this process is actually a part of the electrophilic substitution reaction or the mechanism. Right? So what you can see is the Cl will be replacing the hydrogen from the benzene, and then another chlorine from the Cl2, will combine with the removed hydrogen to produce HCl. So this is the halogenation reaction under the electrophilic substitution reaction. Okay, again, I would like to highlight that instead of using AlCl3, we can also use FeCl3. Okay, if you're using bromine, you can use FeBr3, okay, iron bromide. Okay, you need to memorize this, the list of the reactant and also the catalyst for every electrophilic substitution reaction. Alright, after the reaction, it produces this compound 1-chlorobenzene. Okay, it produces 1-chlorobenzene. Then we have a follow-up reaction involving CH3COCl. as I mentioned earlier, the most common reagent that the catalyst that we are using is aluminum chloride, which relate to the Friedel-Crafts reaction. Okay, make sure you got the correct spelling. So for Friedel-Crafts, we have the alkylation and also we have the acylation. Okay, what is the difference between these two? So alkylation from the word alkyl is referring to R. So the alkylation must attach to the halogen compound. While for acylation, not only going to contain the alkyl group, it must attach to C double bond O, so that it will have the acyl structure and it attached to the halogen. So as you can see here, again, identify it by looking at the catalyst. Okay, what about this CH3COCl? The CH3COCl can be rewritten as CH3 C double bond O Cl. Again, if we look at the structure, we notice that it has the C double bond O. So clearly reaction Y can be named as Friedel-Crafts acylation. Okay, this will be the name of reaction Y. So the idea is, okay, we have our 1-chlorobenzene. Next, we're going to react it with CH3C double bond OCl and then catalysis AlCl3, which is the Friedel-Crafts acylation. What's going to happen is we're going to add the electrophile of CH3C double bond O into the benzene ring. So to determine the position of the CH3C double bond O electrophile, we first need to look at the landlord. Okay, tuan rumah ni kita tengok dulu. Okay, what kind of landlord that we have? Okay, so the chlorine being the first substitute inside the benzene ring. Okay, we know that chlorine belongs to the orthopara director group, which means that although we have 5 available room, okay, remember guys, the substituent which comes later can only occupy the empty room. The chlorine will only allow the CH3C double bond O to be inserted into room number 2, room number 4 or room number 6. Okay, position 1, 2, 1, 4 and also 1, 6 because it is the orthopara director. So if we draw back the structure, it will be looking like this. We have the benzene and then we have the chlorine. Okay, there will be two product, yeah. Okay, the benzene and also the chlorine. So what's going to happen is the CH3C double bond O will be inserted here. First at position 2 or 6, this will be C double bond O CH3, and another possibility is C double bond O CH3. If we insert it into position 6, it's also similar to position number 2. Okay, the ortho configuration is either 1, 2 or 1, 6. The side product is the Cl combined with the hydrogen, which is being replaced at carbon number 2 and also carbon number 4. So the side product will become HCl. This also have HCl as the side product. So these are the two structure that we're looking for, structure C and also structure D. Please take note, make sure you are attaching the structure to the correct attachment. So in this case, since it's been broken at Cl and also C double bond O, okay, kat mana dia putus, kat situ dia sambung. So there we have it, compound C and also compound D. Okay, one is in ortho configuration, the other one is in the para configuration. Okay, what about question number 2? Question number 2, we need to determine reagent 1 first. Alright, although it is not given, we already given the hint that the attachment to the benzene is the NO2. And there is one possibility. In order to replace the hydrogen from the benzene ring, okay, what we're going to do is we're going to add the reagent comprises of nitric acid with sulfuric acid. Okay, this is the electrophilic substitution which is going to produce the NO2 as the nucleophile. So it's very straightforward. It is part of the electrophilic substitution mechanism. Then the next product to achieve E, we're going to perform the sulfonation reaction. So for the sulfonation reaction, we is using SO3 with sulfuric acid. Okay, same like the previous previous question. In order to determine the position of the substituent, okay, we need to identify first what kind of director represented by the NO2. So we know that NO2 belongs to the meta director. Therefore, when we perform the sulfonation reaction, which is SO3 in sulfuric acid, the NO2 will direct the SO3H into the position of 3 or position 5. Therefore, what will to happen is we draw back the nitrobenzene structure, and then we just add the SO3H, which is being produced from the addition of SO3 with the H2SO4. Okay, so this will be the product that we are looking for. Finally, for the last question, here I just clear out a little bit. So from this reaction, from the benzene, we apply reagent 2 to it, and what's going to happen is the H from the benzene will be replaced with CH3. In general, we know that CH3 is an alkyl group. So clearly, this is the Freer-Kraft alkylation reaction. Right, again I want to highlight that the difference between alkyl and acyl is the R group which attaches to the C double bond O. This will be acyl structure. Therefore, immediately we know that the catalyst that we'll be using will be aluminum chloride, and then the Rx that we'll be using, okay, the R is just referring to the alkyl attachment. Therefore, this will be CH3, and of course the X is the Cl, and then the side product will be HCl, the H coming out from the benzene compound. Okay, from here, okay, we already produces the product of methylbenzene, or we know it as toluene. The following reaction, we're going to apply chlorine with sunlight, which also can be written as UV. Instead of using sunlight, this reaction can also replace with heat. Okay, so technically it looks similar with the earlier reaction. Okay, however, we are replacing. Okay, if we take a look back at the structure, For the first reaction, we are using chlorine catalyzed with AlCl3. Again, I would like to remind you guys, we can also use FeCl3. However, we replace the AlCl3 into the sunlight, which means that this is not an electrophilic substitution reactions. So if you remember, during chapter 2, we already discussed this reaction where we use the halogenation reaction and it was catalyzed with the sunlight or heat. Instead of replacing the hydrogen at the benzene ring, this reaction will replace the hydrogen from the side chain. So what we're going to get is, we just draw back the structure, and then the CH3 will release one of the hydrogen, and then we're going to add the chlorine from the Cl2 towards the CH3. The H that is being eliminated from the CH3 will combine with another chlorine atom which comes from the Cl2. So guys, as you can see here, the hydrogen which is located of the benzene is left interrupted, while the hydrogen from the while the hydrogen from the methyl group will combine with another Cl to produce a HCl. This is also named as halogenation. However, it undergoes the different mechanism, which is free radical substitution. Okay, there you have it. This is the discussion for the question to come from one of the questions from the exam papers. So if you have any question related to this topic, okay, please leave a comment below and or you can ask in the Telegram group. See you guys in another video where we're going to discuss question number D. Okay, outline the stepwise mechanism for reaction of benzene with reagent number 2. Okay, goodbye.